So this week we're going to take a look at function notation. I think it's fairly simple, so it shouldn't have too much of an issue. So first thing is, what's a function? Well, with a function, for every input there's exactly one distinct output. Okay, one and only one. So whatever number I plug in, I can only get one output. Okay, if I plug something in and I get two solutions, two answers, not a function. Okay. So we're going to take a look at evaluating functions. Okay, so here we have a linear function. So y equals 3x plus 1. If I said if x equaled 5, well, what's y equal then? We're just taking this 5, plugging it in here for x. So y equals 3 times 5 plus 1. Well, 3 times 5 is 15, plus 1, y is 16. So if I plug in a 5, the only answer I can ever get out is going to be 16. Okay? So that's basically, that's the idea of function. Okay? So now we're going to take a look at operations with functions. Okay? So first thing is, they're going to give us in function notation. So function notation just says this right here. So instead of a y, they're putting it in function notation. So this is function f. Okay, function g, function h. So we can use that. So in letter A, it says find f of 10. So, and again, if we're taking a look at this, instead of the x now is going to equal 10. So we're using the f function. So we're using this first function here, 2x minus 7. Instead of x, we're just going to put in a 10 there to solve. So 2x minus 7. And again, if you want to rewrite it first, you can. But we're plugging in that 10 for the x. So 2 times 10, 20, minus 7, 13. So we can say f of 10 is equal to 13. So in letter B, we're looking at h function, plug it in the 6. So looking at our h function here, 7x minus 2 over 5. And again, you don't necessarily have to rewrite it. You can put the 6 in there. So 7 times 6 minus 2, all of that divided by 5. Again, big fraction. Get one number on top, one number on bottom, and then divide. So if I simplify this top, 7 times 6 is 42. Well, 42 minus 2 gives me 40. And then 40 divided by 5 gives me 8. So h of 6 is equal to 8. Last one here, g function. So g of negative 4. So we're looking at this g function here in the middle. So g of x equals x squared plus 8. Okay, so here's where it's going to be important. Anytime I'm plugging anything in for x, especially with a square, we're putting it in parentheses. Okay, so when I have this x squared, this negative 4 has to be in parentheses. If you don't put it in parentheses, and you type it in your calculator, it's going to be the wrong answer. Okay? So negative 4 squared, or negative 4 times negative 4, gives me positive 16. And then 16 plus 8 gives me what? 24. So g of negative 4 is equal to 24. So Functions can be quadratics as well. So we talked about quadratics, recently here. All quadratics are functions. Okay. Functions can be to the third power. So here's the hardest part of this. Okay. So we did the basic part. Now we're going to kind of put two of them together. Okay, so we have multiple equations and how we can compute them that way. Okay, so if we have f of x here plus g of x, all we're doing is taking the f function and adding it with the g function. Okay, so we're just going to combine the two of them together. So if I do this, f of x plus g of x, well, f of x is 3x minus 5. Then we had the plus, right? G of x then, g of x is just 2x. And all I'm doing is combining like terms now. So x's are going to be combined. So 3x plus 2x gives me 5x. Bring down the negative 5 because it doesn't combine with anything. So here's my new computation then. Okay. Now, that's if they had wanted with x's. If they want it with numbers, it's a little different. Okay. So with the numbers, you can do it one of two ways. You can kind of combine it like we did over here on A, and then take this 5x minus 5. So we still have f of x plus g of x. So now we just have f of 7 plus g of 2. So we can take and combine them first and then plug our number in. Okay. I would just plug the numbers in. So if they give you numbers, plug it in and solve it. Okay. So if I have f of 7, we're just going to plug that in. 3 times 7 minus 5 plus g of x, which is 2 times 2. And now we're just simplifying the whole thing. Okay. So 7 times 3, 21, minus 5, plus 2 times 2 is 4. So then if I look here, negative 5 and 4 makes a negative 1, so 20 minus 1 gives me 20. Okay. So they can also write it like in letter C. So this could be addition as well. Okay, so you can write subtraction like this. And you can also write addition like here in C. So here I have g minus f of x. It's the same thing. Okay. So I'm just taking this g function, 2x. The only thing you have to really be careful of is I'm subtracting everything behind this subtraction sign. So when I look here, 3x minus 5, it almost needs to be in, think about it in parentheses. Because now I have 2x, and when I look at this, this is going to be a negative 3 and a positive 5 and changing our signs. So I would change every sign behind and make an addition. So now I have 2x minus 3x, which gives me a negative x. And then the plus 5 is still at the end there. So the difference when they write it like B and D, so B they have two different numbers they're plugging in for an x of each function, but in D it's the same number. So again, you can combine them like this, and if I just want to take this, if I combine them, I could then take this 4 and plug it in. So I get 1. Or again, I can, if I didn't combine them already, I can just plug the numbers, the 4 in for the numbers. So f minus g, well, I guess not. I switched those, so that wouldn't be the same. That's my fault. If it was g minus f, it would be 4. You could just plug it in. Okay, but here we have f minus g. So f of x, so 3, and again we can plug in that 4. So 3 times 4 minus 5 minus, since there's only one thing, I'm not going to worry about parentheses. 2 times 4 and then we can simplify. So 3 times 4 is 12 minus 5, negative 2 times 4 is negative 8. So then 12 minus 5 minus 8, all of it's going to be negative 1, yes. Okay, good. So again, most people don't necessarily like to work with the x's in there, so if you just want to put the numbers in, solve it out that way, that's fine. Sometimes they will ask you for this specific computation of with the x's in. So here we have multiplication, so we can multiply the two functions. So again, we're taking that g function 2x times f function 3x minus 5. So in a situation like this, what are we doing with these when we multiply? Distribute. Okay, so we're distributing that 2x in. So 2x times 3x, 6x squared, and then 2x times negative 5 is negative 10x, and there's my new computation. Okay. So again, with numbers now, so g of 4, so I have 2 times 4. And all of that times 3x minus 5, or 3 times negative 3 plus 5. So 2 times 4 gives me 8. And then 3 times negative 3 is negative 9, plus 5 gives me what? Negative 4. So then 8 times negative 4, negative 32. So again, the biggest thing is going to be plugging these numbers in and making sure you got the parentheses where they need to be, especially with the calculators. Okay. Alright, so these last four, these are kind of the special ones, okay? So here, instead of the x, what are we plugging in? We're plugging in that whole g function, okay? And then we're going to have to simplify it. So our f function is 3x minus 5. So if I take this 3x minus 5, right, that's my f function. Now we're going to take that g function, okay, so g of x is just 2x, right? So we're going to take this g function and we're going to plug it in for the x. So I have 3 times this 2x, oops, minus 5. And then just simplify, get rid of those parentheses. So just take in this 3. If there's more than one thing in the parentheses, obviously we're going to distribute that again. So 3 times 2x gives me 6x minus 5. So there is f of g of x. So now again, I'll go to these two different ways. Okay, so they're kind of the same. They're just changed around a little bit. I'm doing 2 different ways, so you can pick and choose how you want to. So here I have f of g of 10, okay? So one thing you can do is I can solve for this inside here first, and then plug that number into that f function, okay? So that's kind of what we're going to do. So we're going to look at this, well, what's g of 10? Well, g is that 2x, okay, right? So g of 10 is 2 times 10, or 20. So now I could say, well, this is actually going to be f of, well, what's f of 20? Because that's what g of 10 is, right? Does that make sense? Since g of 20, or g of 10 is 20, we're just plugging that 20 in to my f function. So f function 3x minus 5. So instead of the x, we're going to say 3 times 20 minus 5. Well, 3 times 20 gives me 60 minus 5, and that leaves me with 55. So f of g of 10 is 55. Okay, so that's one way you can do this. Solve for what's in the parentheses for that g function, and then take that number, plug it into the f function. Okay? So going the other direction here, now we have g of f of x. So now we're going to take that g function, which is 2x, and we're going to plug that f function in. So we have 2 times f function is 3x minus 5. And so here, since we have more than one thing in there, now we need to distribute. So we'll distribute this 2 in, so 2 times 3, 6x, 2 times negative 5, negative 10. Okay, so again, these four, these two, this is just another way to write the same thing. Okay. And then the last one, so again, just like we did before, we can take this g function, 2x, plug in my f function in its place, so 2 times 3x minus 5, and then plug in our 2, or negative 2, into my x. So now I have 2 times 3 times negative 5 minus 5. And then I can solve it all as one. So instead of plugging in, finding my value for the one function, then plugging that number in, you can plug that number straight into the function and then simplify the whole thing as a whole. So starting in our parentheses inside, so multiplying, so 3 times negative 5 is negative 15 minus 5, so that gives me negative 20. And then 2 times negative 20 is negative 40. Okay? So again, it all depends on how you like to see it. You know, if you don't care about a bunch of stuff kind of mixed together, you can just write it all out, plug your numbers in for your x's. If you like to keep the equations kind of smaller, you can do one, then take that number and plug it in to the other. Okay? All right, that's functions.